All right, today we're going to talk about trapezoids and kites, so please follow along with your guided notes and fill in where need be. You can pause if you need to, rewind if you need any extra time on anything. All right, so first thing, if a quadrilateral is an isosceles trapezoid, then each pair of base angles is congruent. So quadrilateral, remember that goes back to what we had previously talked about. A quadrilateral is any figure with 4 sides on it there. So we've talked about quadrilaterals with all of our other types of figures. And then we specifically have an isosceles trapezoid. So a trapezoid is a figure that has one pair of parallel sides. We see that in our picture here on the left. RA and TP are parallel. An isosceles trapezoid, 2 of the sides are congruent. We see that there with RT and with AP. And then because it is an isosceles, each pair of base angles is congruent. So we see T and P are congruent, and R and A are congruent. Okay, so that's our isosceles trapezoid there. All right, so our second property of an isosceles trapezoid here is that its diagonals are congruent. So it's actually the same as a rectangle and a square. We see here that AC, this diagonal here, is congruent to BD, this diagonal right there. Okay? Okay, so now we can use these ideas to solve some problems here, to find some missing angle measures or some missing side lengths. In this case, we're finding some missing angle measures. All right, we see that angle C here is 65 degrees. We want to find what is measure of angle D, E, and F. All right, so measure angle D, measure angle E, and the measure of angle F. All right, well, one of those is straightforward. Since in an isosceles trapezoid, base angles are congruent. If angle C is 65, then also angle F will be 65. C and F are congruent. So angle F is 65 degrees, okay? Now we kind of define D and E, which are congruent. They're both the same. So when I find one, I've got the other. I need to kind of use some of those ideas of how many degrees are inside this figure. Well, it has 4 sides. Okay, so if I do my n minus 2 times 180, in this case I'm doing 4 minus 2 times 180. 2 times 180 is 360. Okay, so there's 360 degrees in this figure. Well, I know 2 of the angles are 65. So 360 minus 65 minus 65, okay? So that's 360 minus 130. So that's going to leave me with 230 degrees. All right, so between D and E, we've got 230 degrees. But D and E are equal. So if we take 230 and divide it in half, divided by 2, we get 115. And that is what the measure of both angle D and E are. D equals 115 degrees, and E is the same, so it is also 115 degrees. Okay, so we use the idea of how many degrees were in there and the fact that the base angles were congruent to find those missing angle measures. Okay, this one here, similar type of problem, but now we have our trapezoid and it's just flipped on its side. All right, so we have the angle R is 106. We want to find the measure of angle P, the measure of angle Q, and the measure of angle S. All right, the trickiest thing about when it's on its side is remembering which are our base angles. So since it's on the side, R is congruent to S, and P is congruent to Q. All right, so since R and S are congruent, if R is 106, then S is also 106. And then I'll use the same concept that I just used on the last one. It's a quadrilateral, so it is 360 degrees total. So 360. Subtract R and S, so minus 106, minus 106. Okay, so I subtract those. So 360 minus 212 is going to leave me with 148. And then I will take my 148 and divide it in half, since it has to make up angles P and Q. 148 divided by 2 gives us 74. So angles P and Q are both 74 degrees. And that's how we can use those concepts to solve for missing angles there. All right, another fact about a trapezoid. Okay, if a quadrilateral is a trapezoid, then the mid-segment is parallel to the bases, and that mid-segment, the length of the mid-segment is half the sum of the lengths of the bases. All right, so those are a little tricky, so let's talk here for just a second. So let's look at my trapezoid here, and this is any trapezoid. This doesn't have to be an isosceles trapezoid here, okay? So this is saying MN, this line right here through the middle, is parallel to RA and TP, okay? The mid-segment is parallel to the bases, so all of those are parallel. And number 2 over here, the length of MN is if I take the top and the bottom, so that's TP and RA, so those are these two pieces here, TP and RA. I take those two and I add them together, and I divide them in half. I take half of them, all right, or I can divide them by 2. So add the top and the bottom, divide by 2, and that will give me the length of the middle segment there, okay, which is what we call the mid segment of the trapezoid here. All right, so now let's use that concept here to solve this problem. QR is the mid segment. What is the value of X? Okay, well, we just said that if we take the top and the bottom and add those together, okay, so top and bottom and add them together, so top and bottom. So I'll take those two pieces, 4x minus 10 plus 8, take those two pieces, add them together, and if I divide that by 2, that equals my mid-segment. X plus 2. All right, so now I have an equation I need to solve. First, I get rid of that divided by 2. So we need to multiply both sides by 2. On the left, we're left with 4x minus 10 plus 8. And 2 times x plus 2, remember we got to distribute, 2x plus 4. All right, now I will combine my like terms on the left here. Negative 10 plus 8 is negative 2 equals 2x plus 4. All right, now I have my equation to solve. Draw my line down the middle. Same thing on both sides. I want to make sure to keep things balanced. I'm going to add 2, add 2. 4x equals 2x plus 6. Okay, subtract 2x minus 2x. So we get 2x equals 6. And lastly, divide by 2 to get x equals 3. Okay, so the value of x is 3, and we found that by using the fact that the mid-segment is half the length of the two bases added together. Added the two bases, divided by 2, that will equal our mid-segment there. All right, let's use that concept one more time on this one here. Take my two mid-segments, add them together, and divide by 2. 10 plus 8x minus 12. That's my two bases. Divided by 2 equals our mid-segment, which is 2x plus 11. At this point, probably be a good idea if you want to pause, work through this on your own, and then come back and see if you get the correct answer. All right, I'm going to multiply both sides by 2. Okay, so hopefully you were able to get x equals 6 on that one. We're not quite done on this one though, because that is x, but they also want to know what mn is, what that mid-segment is. So I'll need to substitute x in. Mid-segment was 2 times x, so that's 2 times 6, plus 11, 12 plus 11, so mn is 33. Mn equals 33. All right, our next figure here is a kite. Kite is also a quadrilateral, has 4 sides to it, and it has some specific things that are true of it. If quadrilateral is a kite, then its diagonals are perpendicular. So we see in a kite here that we have 2 pair of congruent sides, so AB and AD are congruent, and then BC and DC are congruent. And we see if it is a kite, then that these diagonals, so a line from B to D and a line from A to C, are perpendicular. Remember, perpendicular lines form a right angle. Okay? All right, so given that, we can find some missing angle measures here in a kite. All right, we are told that the one angle is 52. We want to find the measure of angle 1, measure of angle 2, and the measure of angle 3. All right, well, measure of angle 1, we know the diagonals are perpendicular, so angle 1 is a right angle, which means angle 1 is 90 degrees. Okay, angle 3 is right next to angle 2, and these angles are congruent. That has to do with congruent triangles in there. So those two angles are congruent, so we have this one is 52. And lastly, for angle 2, well, we know the fact that this is a triangle right here. So if I have a 90 and I have a 52, triangles add up to 180. 180 minus 90, and then minus 52 is going to leave us with 38 degrees. So angle 2 has a measure of 38 degrees. Okay, another kite here, finding missing angle measures. Again, pause, figure this out on your own, and then come back and check your answers. All right, so hopefully you got these answers. Angle 1 is 90, because that's where they are perpendicular, the diagonals. Angle 3 is 36, same as the given angle, and angle 2 then is 54 from subtracting those two angles. All right, our last slide here, now that we have gone over all of these different types of figures, just kind of helps to break down where everything is related. Everything starts as a quadrilateral there at the top, and then we see we have kind of 3 different categories. We have a kite, right? No pair of parallel sides. It has a couple pair of congruent sides, but none that are parallel. And then directly below we have trapezoids, and we have two kinds. We have just a regular trapezoid that has just one pair of sides parallel. Then the isosceles trapezoid, which is a little more specific, has one pair of sides parallel, but also the other pair of sides are congruent. And then we have our parallelograms, which have two pair of parallel sides. And then we had our special parallelograms, our rectangles and our rhombuses, and then the square, which was a combination of those two.